Welcome students. This video is made for third year mechanical engineering for the subject ME 8691 computer aided design and manufacturing. In this subject we are going to see the unit 5 cellular manufacturing and flexible manufacturing system. In this unit the first topic is a group technology. Group technology is the manufacturing values in which similar configured parts are identified and grouped together and take the benefit of the similarities to achieve the higher level of integration between the design and manufacturing and function of the film. Similar parts are arranged into a part families is called as a group technology. So the group technology where we are implementing, there are two major tasks that company must undertake when it implements a group technology. Identifying the part families is the first one, and second one is rearranging the protection machine into a cell. In the first point, identifying the part families. For an example, if a plant makes 10,000 different components or parts, are able to group these components based on the design manufacturing into 30 to 40 different families. Each part or family is similar. And this is known as a cellular manufacturing. And the second point is rearranging production machines into a cell. So it's a time consuming and costly to plan and accomplish the rearrangement, and the machines are not producing during the changeover. So it has a different methods to identify the part families. So it is categorized into four methods: visual inspection, composite part method, production flow analysis, and parts classification and coding. So in this first method, visual inspection method, it is simple and economic process in which parts are identified by looking the physical parts are photographed and grouped together to form a part family. So it has a two image, so you can able to see the two image, two different type, but it has a similarities in same material or same dimension or same machineries. So we are identifying with the parts. This is called as visual inspection method. So for an example, they are categorized into four families based on the physical appearance. This is called visual method, and this is also known as a group technology. And second one is a composite part method. In this method, we are identifying the part families based on the manufacturing or components. For an example, the following figure shows the operations on lathe. So you can see the image. So it's a rod. So you can see here it's a plain rod. So it is going to change over in the machine, and using a lathe, we are going to turning or facing so many operations. So it is known as a composite part method. So each job need all this operation. So an imaginary component involves all operations needed for the group. And then third one is a production flow analysis. In this method, it has a 4 basic steps. So production flow analysis, it has a procedure. It's a technique which a part families are identified using a root sheet or rather than a part diagrams. So it has a procedure also. So first it needs to collect the data collection and the sorting process and production flow analysis chart, and then finally cluster analysis. So in data collection, the data needed for the analysis are part number and operation sequence. So both are contained in the product root sheets. Each operation is usually associated with a particular mission. So determine the operation sequence. So we can easily identify the sequence and determine the mission sequence also. And then the second process is sorting process. So it is also known as a routing process. In this step, parts are arranged into groups according to the similarity of the process routings. All machines which are producing the same part are allocated with code numbers according to the sequence. This is known as a sorting process. And next process is a production flow analysis chart. So PFA is also known as a part machine incidence matrix. So parts are identified using alphabets along rows I. Machines are identified in number along column J. So using the formula Xij is equal to 1, the matrix entries. So value of 1 indicates the corresponding part I requires processing on machine J. So based on that, we are going to do the cluster analysis. So from the matrix step, the related groupings are identified and rearranged to a new pattern with similar machine sequence. Is known as cluster analysis. And then fourth point is parts classification and coding. So in this topic, design and manufacturing areas are get benefited on the part classification and coding. Most of the classification and codings are similarities. It's classified into 2 parts also. So first category is design, based on the design attributes and based on the manufacturing attributes. In design, it has examples like geometry, the size and material. And manufacturing means the sequence of processing steps to make the product, like operation sequence, the dimensions, surface finish, mission tools. So these are the manufacturing attributes. Important coding system. So we have 3 important coding systems: Optis, MI class and code system. Optis coding system It was developed by H. Optis. So it is proposed for machined parts. So it is one of the first published coding scheme for mechanical parts. Optis coding scheme consists of 9 digits, can be extended by adding 4 more digits. The first 5 digit, the digit 1, 2, 3, 4, 5 is called as form code, and digit 6 to 9 is called as supplementary code, and followed by ABCD. That ABCD values are in the digit 1 inside itself, and these are known as a secondary code. In the Optis coding system, the first 5 digits are called as a form code, which describes design attributes of the part such as external shape and machined features. The next 4 digit 6 to 9 are called as supplementary code, which indicates the code related with the manufacturing such as dimension, material, the original shape of the raw material, accuracy, surface finish, etc. The additional 4 digits depends on the manufacturer.